Exercise 1.1, question 5. Use Euclid's division lemma to show that the cube of any positive integer, so any positive integer, again I'm going to call this x, very similar to question number 4 of this exercise. I encourage you to watch that first if you haven't already. So you have to use the lemma to show that the cube of any positive integer is of the form this, or that. Now if x is the positive integer that I'm taking, then its cube can be represented by x to the power 3, and this is what you have to show is of one of these forms here, one of these. Now how you start this is exactly what we did in number 4. You will consider the number x as any positive integer. Let me just write that statement down. There you go. And then according to the Euclid's division lemma, you know that you need the divisor also. So you really have to be given two numbers. One of them becomes the dividend and the other becomes the divisor. So in my case, instead of a, I am taking this x as my dividend, and the divisor, which is b, is given by the number that you see here in these three forms. So it's 9, a multiple of 9, or 1 more than a multiple of 9, or 8 more than a multiple of 9. So it's 9 whose multiples you're looking for. So this is what you take as b. So let x be any positive integer and b be equal to 9. Then when you apply Euclid's lemma on x and 9, you will know that when you divide these two, there definitely will be a quotient q, and ultimately there will be a remainder r, which can be anything greater than or equal to 0 but less than 9 for sure, and therefore you can write it using our lemma as x is equal to 9q plus r, where yet again you know what r is. This is the range of values of r. Now this will give me a lot of possible values of x based on different values that r can take. R can be 0, 1, 2, 3, 4, 5, 6, 7 and 8. So let me write more r values here. This, it cannot be 9. For each of these you will get a value of x. This is going to be 9q plus 0, or I can just say this is going to be 9q. Then the next one is going to be what? 9q plus 1. Then you're going to have 9q plus 2, 9q plus 3, all the way till here where it becomes 9q plus 8. So there are a lot of possible values that x can take this time based on this remainder r. Because of the various values that the remainder can take, your x is also taking many possible values here. Now for all of these values for x, you have to see x to the power 3, because that is ultimately the one that you want to talk about. That has to be of this form, 9m, or 9m plus 1, or 9m plus 8. So what you need to do is you need to cube each of these numbers. So it's a lot of work, but the idea is really simple. The idea for this solution is from question number 4 only. So it's very important that you understand that very clearly. After that, when you need to cube this, you would see that it's just mathematical. It's just calculations after this. So when you do this, this becomes 9 to the power 3 times q to the power 3. Now, if I want to express this as a one of these three, so say this is form 1, form 2, and form 3 on top, I can definitely express this as 9m, because this is a multiple of 9, right? It'll be 9 times 9 squared, which is 81, q to the power 3. So this will be form number 1 for me. Similarly, you will have to do each of these and then see which form you can get. So just pause the video and do all of that, do all the cubes there, and only then play the video. When you play it, you will see all the cubes written. Alright, there we go. Now before I begin, there might be some of you who do not know how to cube a sum. So I will just begin by telling you the identity. So a plus b whole cubed is equal to a cubed plus b cubed plus 3, a squared b plus 3 AB squared. So that is the identity that we have used throughout. Now just observe. This first one, where r is equal to 0, I see that my x cube is a multiple of 9. So without thinking twice, I will just say it is 9m. So whatever is the rest of it after taking my 9 out, that will become m. When I look at the next one, I can see that there's a 9 here in this first term, in the third term, as well as in the fourth term. So when I take 9 common from these three terms, whatever will be left inside, I will just call that m, 9m, plus this 1 that is left over here is what I will write, 9m plus 1. So where am I getting this one again? There's this number which I got by cubing 1. 1 to the power 3 is 1. So this gives me the second form as you see here. Again, let's go on. So two of them are done. In this third one now, you will see 9 in the first term, in the third term, and in the fourth term yet again. So when I will take 9 common from all of these, I can get m as whatever is left inside. But that way, what will I be left with? I will be left with an 8. And that is perfectly fine for me. So I will just say 9m plus 8. This is exactly form number 3 that we are looking for right here on top. So till now, the first 3 that we did, we showed that they are indeed in the forms that we want. Coming to this one now, number 3, where r is equal to 3, you have 9 from term 1, term 4, and 3. Yeah, from 1, 3, and 4. This time though, 27. 27 also has 9 as a factor because 9 threes are 27. That means I can take 9 common from the whole thing, and whatever will be left inside, that will be 9m. That will be m for me. So till now, let me just summarize what we have. This is form number 1, form number 2, form number 3, and back to form number 1. We're done with the first 4 cases where r is equal to 0, 1, 2, 3, and now let's go on and see what happens if r is 4 through 8. Any number in that range. All right, there you go. So yet again, you will see 9 in first term, third term, and fourth term. In fact, that is going to happen in all of these if you observe carefully. All of these, because of the way the identity is formed, will have 9 as a factor in the first, third, and fourth terms. So really it just comes down to the difference, to the number that is left, the constant, which will give me one of these three forms. Now in the first one, what I have is I have 9 common from these and then 64. Well, I'm not allowed to have 64. My constants can only be either just 9m plus 0 or 9m plus 1 or 9m plus 8. So what I can do is I can write 64 as 63 plus 1, and then this 63 again will have 9 as a factor because 9 sevens are 63. So when you will take 9 common from all of these pink highlighted parts, the only thing you will be left with is a 1 on the outside. It is this 1 that will be left. So this is again in form number 2. Let's move on and see the next one. Again, when I take 9 common from these, I only have to think about the 125. What do I do? How can I express this? How can my constant become 0, 1, or 8? Well, 125 is not divisible by 9. When you try and divide 125 by 9, let me show that. So it's 9 ones are 9, 35, 9 threes are 27, 8 will be your remainder. That means this is going to be a multiple of 9. Whatever that multiple is, it's really going to be 9 times 13, whatever that value comes out to be, plus an 8. So really, I'm just breaking this down into two numbers. Definitely the other one has to be 117. And now that 117 is 9 times 13 for me. So if I take 9 common from all of these pink terms, I will be left with 9m, whatever is inside, plus this 8 that is left. This is the 8. And now this is form number 3. In case you haven't already noticed, the forms are repeating. They're going in a nice cycle. I'll just show you what has happened till now. You had 1, 2, 3, then 1, and then 2, 3, and then naturally I can assume already it is going to be 1, 2, 3 again. And that you will be able to see when you notice that 216 is definitely divisible by 9. Try dividing and you will see that 216 has 9 as a factor. So this will be of the form 9m, which is yet again form number 1. Then 343 can be broken into 342 plus 1, and 342 will again be divisible by 9. So I will be able to take 9 common from 342. So what I'll be left with is 9 times whatever is inside plus 1. And that is form number 2 for me. Finally, when you divide 512 by 9, you will see that the remainder is 8. The nearest multiple is 504. So this is 504 plus 8. So I can take 9 common from 504 also. And overall, what I'll be left with is 9m plus 8. It is this 8 which is the remainder here, this one. So this is back at form number 3. Now we had gotten the idea for this when we were doing this. I didn't want to assume that you would understand anything, or I wanted to do every single step for you here so that no matter what level of question they throw at you, you never get scared by it. If we can do this complicated question, and you see it was just repeating the same process again and again. It was not anything different that we were doing. You were just trying to express it as a multiple of 9 or a multiple of 9 plus 1 or a multiple of 9 plus 8.